Welcome to Fuqua LinkedIn Live Series. Today, we're going to be talking about business decisions with AI, focusing on causality in data. Right. So the plan is for me to be speaking for about 20 minutes. Please drop any questions on the chat, and then after, we're going to answer those questions. Quickly, just a note about me, right? I'm Alex, and I have this somewhat long title. Essentially means that I have been working at Fuqua for about 18 years, and also have been working with Amazon for the last 6 years. So I have been having the fortune to learn from Fuqua, apply to Amazon, learn from Amazon, and bring to my teaching at Fuqua. So my research is actually on AI, causal inference, that we're going to talk a little bit about today, statistics, how to design ways to sell things better, and how to optimize systems. Outside academia and industry, my family is really interested in animal conservation. We work with local organizations and international organizations to try to help that particular topic. But let me talk back to business with AI, right? The setting that we're living today, that businesses are engaged with more customers in many more ways, right? Which means that business needs to make decisions and faster decisions, right? And AI is playing a key role in this setting because it allows us to scale in terms of the volume of decisions we can make, or the volume of customers we can actually serve, the speed we can serve these customers, and how well we can personalize to each customer. This is all consequence of AI, right? If you take to the limit today, right, to the kind of state of the art, right, now LLMs can create different agents that are going to interact, influence these customers, and each of these agents going to have different performance. To some extent, what we really want to know is kind of how to sort out, how to decide which is the best agent, which is the best option we need to actually use in our systems. So to do that, in the end of the day, we need to understand what's the value added for any particular option, right? And we're doing this in a setting that is becoming increasingly more competitive, so we need to move faster. We need to also handle many businesses with decreasing margins, which means that we need to innovate more, right? And once you go for innovations, there is this natural tension between innovating and knowing that it's going to work. Because if you're really being innovative, you do not know if it's going to fully work in your setting or not. So there is this nice quote about from Jeff Bezos that indeed failure and innovation goes together, right? Because if you're not failing, it means that you're not trying to innovate enough. Right? So you're always playing with this boundary. So you need to experiment at the end of the day, right? So basically, moving forward in business, right, it's critical to identify and understand what's a good decision, right? What's really the value added for a new customer experience? What's the value of the return of investment of a new ad? And to some extent, we need to avoid preconceptions, right? We might think that our idea is great, but it's really a dangerous situation to be so sure about it that you don't see blind spots, right? So the bottom line is that opinions and intuitions are very important to drive business, right? We do a lot of that. It usually gets you in the right direction, but it's very hard to quantify. When there were very few options, this might be good enough. Now that we're actually dealing with many, many variations, this intuition might not be enough for you actually to move forward. So here's where causal inference, which is a particular field that I work on, that tries to understand cause and effect, right? In a deep level, not simply correlation, right? We need to understand causation. It's, of course, relevant in many empirical fields and became widely used now in industry across the board. I think the prime example that many of you, if not all, are familiar is the idea of A/B testing that has been a critical tool to actually bring innovation, to show that an idea is good. So a very quick recap of A/B testing, and you can think about it. If you have your users and you have two ideas to test, you split randomly your users, you create this control group and this treatment group. For the control group, you give them user experience. For the treated group, you give them the new experience. So you can measure their performance. You can measure how much a customer purchased in your system, or you can measure how much time he's interacted with your system in your platform, and then you can compare results. It's a simple idea. It is indeed the scientific standard that if you can do that, you should be doing that. And it is really critical that you do this random assignment, that you split these groups. Because what that does for you, it creates two very similar groups. Basically, these groups have similar characteristics. Anything you can think of, they are pretty much a good match. But the real beauty is that even if you did not think about something, this procedure also makes these groups balanced, make them very similar in these things that you do not know about, not even think about. Why that's so critical is because this process can scale very well in industry. Essentially, it means that if I'm going to try two ideas, I do not need to be an expert on the topic to be able to tell apart which was the best idea. And that's a huge shift because all of a sudden, all my software engineers don't need to be an expert in the customer experience psychology to try two options and see which one works better. You can do this in parallel, so you can do many of these tests, so you can actually try out many different options to zoom in on something that's going to improve the business. Quite reliable. So there are many examples. So one quick example, just to fix ideas. For example, this Obama presidential campaign, there were many options to create ads for the campaign, so for people to sign up to collaborate, right? You can create many combinations, but there is a huge difference in performance across those. And by performing kind of many of those A/B tests, essentially they were able to actually improve the revenue of their campaign by 40% by identifying a proper combination. Other questions you can answer, for example, working from home and the impact of productivity. You can actually, and this was an experiment that was done recently, and indeed a particular travel agency with a couple of thousands employees, they decide to randomize who will be assigned to work from home and who will not, and measure outcomes. Indeed, in this particular company, you were able to actually measure improving performance by 13%. And it can even break down where the improvement comes from. So another nice thing about this A/B test that going deep on the data tells you the mechanism of improvement. So you can actually learn to potentially improve things even further. So just a quick summary, right? This A/B test has been critical to bring hard evidence into decisions, right? It's a very systematic approach that gives you an unbiased assessment. And sometimes it's high cost, sometimes it's low cost, right? Depending on the experiment, depending on the setting you are dealing. But the important thing that you can accept failure quickly, right? You don't need to double down on an idea for too long, right? So we would like to say that these can avoid one-way doors. I don't need to change my whole system to a new customer interface without knowing that actually works. So we can postpone the decision after we know it's actually a good decision. And what typically happens is that big wins, they're going to pay for way more than sufficient for many experiments. So, not surprising, this became extremely useful in online platforms where you can manipulate the customer experience very well and at scale and very fast. You can track metrics, you can actually understand how things work. So that allows many online companies to actually take advantage of that and fine-tune their performance quite a bit. Okay, so this is my intro, right? Because I want to answer the question, like, can we always conduct an A/B test? And the answer actually is no, right? There are going to be many situations, and for very good reasons, where this kind of very robust procedure cannot be applied. So let's go just mention two examples, right? So imagine a situation where we're going to talk a specific example in a moment, but if you split groups into control and treatment group, but then all of which customers, when you give an offer to one customer, he can actually choose to accept the offer or not, which is widely common in our settings. So that is something that's going to violate this A/B testing initial important system. Another situation is if I have a setting where my customers actually talk to each other heavily and they interfere with each other. So all of a sudden, if I give an offer to one customer, that change the behavior from another customer. That can make things very hard for me to tease out what is actually good to the system, for the system. So let me talk about the first situation, which typically we refer to causal analysis of observational data. So here we have the data without a fully nice experiment, like A/B test. And what happens there that it's impossible they're going to be biased. Right? Understanding the design of how the data was given to you is critical. Just one simple example. Suppose you are interested on estimating the treatment effect of prime cards on customers' purchase. So what's the main issue? Well, the main issue is what we just mentioned, that unlike the 70s, customers have the option to sign up for credit card or not. The company is not deciding who gets the credit card. What you can do is you can give an offer, and some customers are going to choose to get the offer, and some customers are going to pass on the offer. The problem with that is, even if you give the offers randomly to a group that was nicely balanced, this choice of taking upon the offer is done by the customer, not by us. So this introduces what we call a selection bias, the selection of the customer, or let's say the unit of study. So what ends up happening is that the group of customers that select to get the offer, they might be quite different from the overall group of customers. And if this is different, then I don't have a balanced comparison. I don't have a fair comparison between these two groups. And this was not the case with A/B test. That was the magic from A/B test. So indeed, if you do a direct analysis, you would undervalue the impact on purchase by 50% in this particular situation. So this is a very active research area. I spend a lot of time thinking about those problems. So indeed, this selection bias that comes from the customers, which is very common in many business settings, creates unbalanced groups. And to actually fix things, we need to think a little bit more about what are the counterfactors. What would have happened if all customers had accepted, which is a slightly different mindset. So to achieve this balanced comparison, we're going to have to control for other factors. We're going to have to do actually more work, right? So our analysis might have to be more complicated. So in particular, we can leverage AI to achieve this balanced comparison. But to do that, we're going to go back to understand how the data comes to you, right? So basically, at time 0, you can figure that you give an offer. At time for a customer, for time 1, the customer chooses to accept or reject the offer. But this is not random. This depends on the customer's own view and projections, if it is good for them or not to accept the offer. And then we measure the outcome. Like for the customers who accept the offer, we measure the outcome of having, let's say, the credit card, and the customers who chose not to get the offer, we measure how much they spent while they do not have the credit card. Turns out that we can use AI, more specifically machine learning, to predict what is the potential metrics, like purchase they actually do in each scenario. But we also have to use AI or machine learning to estimate the propensity for each one of them to accept or reject the offer. Because that propensity, by not being 50-50, by not being equal across customers, change the pool of customers I'm dealing with. So by combining these two informations, we can undo this selection bias, and it's in artificially creating a balanced comparison that allows us to understand which option is better. So we can properly estimate this impact with groups which are unbalanced from the data, but we artificially balance them. So this process is highly scalable, highly applicable in industry, It's very easy to onboard and has the driving a lot of better decisions. On the other hand, we can think about situations where customers are connected, right? So that we call causal analysis with interference. And even if you do a random experiment here, and people take the treatment randomly as you would like them to take or not, because one customer impact another one, that can create all sorts of issues. So just quick examples, if you think about vaccination and how a disease propagates, if I have a lot of people who are vaccinated around me, I am somehow shielded to be potentially infected. So that is a system that the value of vaccination depends on who else is vaccinated. If you think about Ubers, customers are being matched to drivers, right? And if you give particular incentive for one of the customers, that potentially change the offer for other customers to get the rides as well. So that has an impact across the platform. Or even more simply, if you think about after-school programs where students can go to this after-school to actually learn more of a particular topic, their friendship can create kind of percolation of information within the after school, but also in the school friends themselves. So you see a lot of this, what we call interference. If one of the kids go, that can actually affect another kid who was not in the program at all. So, for example, just to illustrate how these things can get complicated, I think, suppose we want to do the following experiment in Facebook, want to understand the effect of replacing emoji icons with a button. So this is the control group that you can see in the bottom that there are multiple buttons. And I want to change that experience to having only one emoji, right? And the experience depends if you're on Android or an app. So we would like to understand which option is better. Well, when we think about treating these, we need to understand that who are we actually impacting? Because we're impacting the experience, how the story is being shown, but there are story creators and there are the users. If I want to understand the impact of changing that, it can affect both sides. How do I reconcile that? But the intuition is always the same. Right? The intuition comes back to the A/B testing that I need to create somehow a fair comparison. So I might design an experiment that randomly change this user interface for story creators or for the users. But depending on what I do, changes what I can learn from the experiment. So there are different ways to approach this. One is to try to take care of this interference in the design phase of the experiment. Another one is to try to take care of it after the experiment is done in the analysis. So I'll create models that are going to be more sophisticated to try to correct for bias. Right? In different applications, we're going to have both options. Right? So just to sum up, right, there are many ways to create these fair comparisons, these balanced comparisons for specific questions within these complex systems that we see in business these days. But there's a lot of different ways to do it, right? Switchbacks, crossover, cluster designs, matching, synthetic controls. There are all sorts of different tools that can be applied to different settings. They cover different specific situations, right? And indeed, in the complex systems we are dealing today in business, right, this causal inference emerges as a very effective way to actually assess the value added of proposals, right? And we're gonna need both, right? Design of good experiments and also good models from AI to actually enrich them so we can learn and develop better. With that, I would like to thank you, and I'll open for a few questions. So I see one question in the chat. How prevalent are these tools in the industry today? My experience is that tech giants, they are using these a lot. That's what I see around. Right? So tech giants they're really they saw the value of this early on, and they heavily invest in these tools. They embrace experimentation, and they are doing it. Of course, many companies, they are at different stages of their evolution in terms of how sophisticated on these tools they are. Some companies are going to be starting to do A/B test, but not having experimentation today, it will be very costly. Right? You really need to have some system that still has a huge competitive advantage that doesn't need to be fine-tuned for you not to be leveraging those tools. These tools, at the end of the day, they are relatively cheap, so they can add a lot of value in your system. I have another question. How do you study the customer propensity to accept the offer? Good question. This start to get into the details, but the good news there is that the propensity to accept the offer, it's about observables. We're going to be able to see if we made an offer or not for a customer, and then we're going to get to see if the customer accepted or not. Based on that, and typically the characteristics of the offer and the characteristics of the customer, we can actually build some machine learning model that assess that propensity for us. And that's one of the important results in causal inference, that once you know that propensity, that's the only thing you need to undo this unfair comparison, this unbalanced comparison, so you can rescale things properly. Good. Another question that I got, are these topics being taught at Fuqua? The answer is yes. Let's say, I want to say that at least half of the things we talk today are being covered at current Fuqua classes. I teach one of them. And there is another new class that we are developing that will cover the integration between AI and business. And some of these causal topics would be part of that. Okay, another question. Good. I am curious about the 6 weeks course scope. Would there be finals, midterm project, house team base, group work? Yes. So welcome to Fuqua, right? The 6 weeks course scope, at least the one I teach, there is a final, there is projects and case, right? Which is the team-based case, right? So yes, we cover that. Many courses at Fuqua will have this format. This has a particular hands-on component that pushes you to actually think about how to deliver value through a machine learning AI prototype. Good. I have another question, is why the Uber incentive to one rider affects other customers. So we can talk about specifics of Uber, but it applies to many other settings, right? You can think about all these platforms that are matching customers and providers. And what happens that if you give all of a sudden a particular incentive to one driver for a particular region of customers, you are essentially making the driver to be more likely to switch to a choice to that side, impacting the waiting time, let's say, of customers not in that region, for example. So the customer experience of other regions that had nothing to do with the parties treated actually gets impacted. So that's one example where you can have that. Okay, another question is, what are the specific tools you look at your course? How much is hands-on learning, projects, and use cases? Okay, so basically we go over kind of a fair amount of tools, right? There is hands-on on the case and the project, which is a team-based setting. My view that the hands-on with coding, let's say light coding and driving these problems, which are a little bit open-ended, are best suited for team-based activities. Right? Finals are more conceptual that you are doing individually. Right? That's how and indeed we go over some causal and predictive cases. So there are two separate things that we're going to be able to cover. Right? Yes, and these tools are definitely applied for estimated return of investment in marketing. Okay, another question is, what are a few use cases that are applicable to a small business given cost? Well, so again, the idea of A/B testing, right, has been definitely used to large and small business, right? So think about just changing the way you interface with customers, right? Are you gonna, for example, if you run a small business and you are in a business that you need to reserve a slot, people can reserve the slot but not show up. Do you want to actually charge a fee if they're gonna decide not to show up? We can run an experiment for that. Instead of changing the whole business to one side or another, you can try both in small groups, so we'll decide what is actually the value there. I have another question is there any link for 6-week training? So 6-week training for, like there are we have the MBA courses that run in 6 weeks. And there are some executive courses that I think Fuqua runs. They are not necessarily 6 weeks, but that's a separate activity. We have a few more minutes to go, and if there are any other questions, I'm happy to answer. And what I hope you got from the live session today is just this idea that if you want to understand causal effect, you need to somehow generate this nice balanced comparison, right? The groups of people that are gonna receive some sort of offer or not, these two groups, right, they're actually gonna take some sort of offer and gonna reject some sort of offer. They need to be balanced. And sometimes it's tricky to actually do it because we are living in a very kind of interconnected world that creates a lot of challenge to actually understand. Yes, so the accelerated MBA programs, they come to take electives, and these courses that I'm talking are electives, so that should be offered to them as well. Good. Look at the time, we are almost at time. So if there are no more questions on the chat, I just one more time would like to thank you all for being here, for joining us today, right? And next month, please join Professor James Emery on August 6th for another talk on the series. And he's going to talk about how the consulting industry will develop the next generation of talent that actually need to tackle AI. So again, really a pleasure to have been here today. And I hope this, again, sparks an interest on AI, causal inference, and all these emerging topics that are actually driving a lot of business these days.